Okay, good morning. So today we also want to talk about a new topic, and under the title of Inequalities. So you know that this is equality sign in mathematics, and then when we say that the number A is equal to B, it means that the values are the same. But inequalities, we have more or less four symbols for them. So we can use this symbol, we can use this symbol, and we can use this, and of course we can use this. These are the symbols that you might see in this lesson under the title of inequalities. Okay, so this is red, less than, so this we read less than or equal to. And this is read greater than, and this is greater than or equal to. Okay, the ideas are clear. For example, we can say 1 is less than 2. It's a true statement, yes? Of course, if I write this is true, I can say that 3 is less than 2, and of course this would be a false statement. Yes? So, what about, for example, this one? If I write 1 is less than or equal to 3, is that true or false?
False.
True or false, this one?
False.
No, this is true again. Yes? Because you say that 1 is less than or equal to 3. This is not a false statement, even though 1 is not equal to 3, for sure. But in mathematics, if you have two statements that are actually connected with or, for that statement to be true, at least one of those statements should be true. Of course, if yes, for example, this means, in mathematics, instead of saying this means, we say is equivalent to. This sentence that you see, this statement that you see, is equivalent to saying 1 is equal to 3 or 1 is less than 3. This symbol that you see here is a compact form of writing this whole expression. Yes? And of course, this expression is composed of two statements. One statement is telling you that 1 is equal to 3. One statement is telling you that 1 is less than 3. Of course, this statement clearly is false, but this statement is true. But you are using or. So, if you use or, the whole statement becomes true if at least one of these statements is true. Yes? So if I ask you, what is the value of this statement? This is a compound statement. This is a simple statement. This is also a simple statement. I am connecting them with this or, and this would be a compound statement. This compound statement is true if and only if at least one of the statements are true. One of the statements is true. Okay, so here in general, 1 less than or equal to 3 is a true statement, because 1 less than or equal to 3 is the short form of this expression. And in this expression, even though one of the statements is false, the other statement is true, so the value for the whole statement is true. Yes? And then this means that this expression is true. Is that clear? So let me write this. This is good to know. When we say that A is less than or equal to B is equivalent. In mathematics, if you want to say two statements are equivalent, you use this symbol. A less than or equal to B means either A is equal to B, or if you want to, let me just use this symbol. This mathematics means or. A is less than B. Okay, so that is a symbol that we use for or. Yes? Okay, so this is something that you need to know. If you want, we can translate the other way around. So what is the meaning of A is greater than or equal to B? This is equivalent to saying that either A is equal to B or A is greater than B. So these are the things that we don't mention anymore, we are using them. Yes? Okay, so let us compare the properties of these inequality signs with what we have here. This is a relation between these two numbers. This is also a relation between two numbers. You are relating them somehow here. So equality is symmetric. What does it mean? It doesn't matter if you say A is equal to B or if you say B is equal to A. They are completely equivalent, yes? So you say that A is equal to B is equivalent. It doesn't matter at all if I write B is equal to A. B is equal to A carries the same information for me as A equals to B. But in inequalities, of course, it is not symmetric, yes? If I say A is less than B, if I say this is equivalent to B is less than A, of course, completely wrong, yes? But you can write it in an equivalent way. So if you want to swap A and B, here you don't need to pay any price for that. You just swap them. And if this is true, this is also true and the other way around. But in inequalities, am I allowed to swap? Yes, you are allowed to swap, but then it is very natural. What should I write if I want to swap? If I want to write A on the right and if I want to write B on the left, what should I write? Yes?
B is greater than A.
Greater than A. Yes? So that's important to understand. This is very important. In equalities, if you want, you can swap them without any care. But here, when you want to swap them, am I allowed? Yes, you are allowed, but you have to be careful to change the direction of this inequality. Of course, it is clear that if I start with greater than, if I want to swap them, then what should I do? I can swap them. But what should I write here? A is greater than B means B is less than A. Of course, this is clear. You really don't need a teacher to teach you these things. But I want you to compare these kinds of relations that we can simply swap without any changes. That would be that is called a symmetric relationship, a symmetric relation. But less than is not symmetric. But can I find a way to swap them? Yes, you swap them, but you need to remember to change the sign. Yes.
Shouldn't the sign on the right side be greater than or equal?
No.
And less than or equal?
Why?
I don't know, maybe I'm confusing.
No, because I want to write equivalency. So I am saying that these two statements are true. If A is strictly less than B, there is no chance for B to be equal to A.
That's true.
Yes?
Yeah, no, I'm probably confusing.
But no, might be you are confusing yourself with this one. If I write A is less than B, by the way, can I conclude this? This is important from a logic point of view. Can I conclude that A is less than or equal to B? Let me write something else. If A is less than or equal to B, can I conclude for sure that A is less than B? So which one of these implications, if any, is true? Yes?
The first one is true.
The second one
is false.
is false. Okay? The first one is true. When you say that A is less than B, if I want to, I can conclude that A is less than or equal to B. Of course, this is not a wrong implication. When you are saying me that A is less than B, there is no chance for A to be equal to B. But if you say from A less than B, I can conclude A is less than or equal to B, that is not wrong. The wrong part is going back. In general, if I have or statement here, I am not allowed to go back. Yes? So let me just clean this one. And then if something you can go forward and not backward, then they are not equivalent in mathematics. So the first one is true, the other one is false.
I now know I confuse it with if you know that A is not greater than B, then you know that B is, or that A is less than or equal to B.
Yes, yes. So that is called that is a different thing.
Yeah.
This is called a negation of a statement. So this is the symbol we use for negation of a statement. Let me just, by the way, describe for you what a statement is. Statement in mathematics is a declarative sentence. It declares something. You full stop. You put the full stop at the end, and then it is either true or false. That is called a statement. So when I use a statement, I mean a declarative sentence which is either true or false, but not both. For example, 1 is less than 2 is a statement because I'm declaring something, and the value of this statement is either true or false. But for example, what a lovely day is not a statement in mathematics because it's not a declarative sentence. So usually you end up with an exclamation mark there, yes? So a statement in mathematics means a declarative sentence which is either true or false, but not both, even though we don't know if this is true or false at the moment. Yes? Okay, and then this negation means not something. Okay, so when you say 1 is less than 2, 1 is less than 2, this is a statement. Yes, because it is declaring something, and it might be true or false, which in this case is true. Negation of this statement, you should say that this is not the case that 1 is less than 2. Of course, we don't speak in this way in this normal language. We say that 1 is not less than 2. So 1 is less than 2 in the mathematical symbol is written that. But if I say that what is the negation of this statement, one way of writing is to say 1 is not less than 2, but this is not that common. Instead of that, we should write what, as Rasmus mentioned clearly, 1 is greater than or equal to 2. Yes? So when you say that 1 is not less than 2, it means that there are two possibilities for this to happen. Either 1 is equal to 2 or 1 is greater than 2. Okay, so don't get confused with these things, but this is something that I want you to know. It's very, very important. So if you want to interchange these sides, you are allowed to do that, but the price that you have to pay is also swapping the direction of inequality. And of course, let me do not, if I want to, because there are 4 inequalities, all of them are true for, these things that I'm writing is true for all of them. For example, if A is less than or equal to B, this is equivalent. Can I swap these two? The answer is again yes, but the price that I have to pay is to swap the direction of this, actually, to swap this to that. Yes? And the other way around. If A is greater than or equal to B, this is equivalent to saying that B is less than or equal to A. And the correct adjective to use is greater than or and less than. This is the formal way. But sometimes I say larger or bigger or smaller. But you need to know that if you want to use the correct word, the correct adjective, this is less and greater. Okay? Okay, so that is something that I want you to know. And let us now go and review some properties of equality relation to see if they hold also with inequalities. Yes. For example, one of the very, very famous properties of equality. So we discussed about symmetric property. Equality relation is symmetric. These words I don't want you to learn, but I want you to hear. If you are interested, of course, you can learn, but this is not obligatory. Equality relation is symmetric. Okay, another point is that equality relation is reflexive. Okay, another one is equality relation is transitive. So if you are interested, these are the words that you might want to learn. Okay, let me discuss about that. We already discussed about symmetric relation. If A is equal to B, B is also equal to A. That is the meaning of a symmetric relation. Yes? What is the meaning of reflexive? Every number is equal to itself. Yes? So equality is reflexive because every number is equal to itself. Yes? So this means that A is equal to B. One can immediately conclude that B is equal to A. This means being reflexive. Sorry, being symmetric. Reflexive means that any number that you imagine is equal to itself. Yes? Okay. Is transitive, what does it mean? Of course, these are fancy names for simple properties that you already know. Yes? So transitive means that if A is equal to a number B and simultaneously, this is the symbol we use for and. That was for or, this was for and. If A is equal to B and B itself is equal to C, you don't even need me to answer what will happen then. What is the conclusion immediately clear for you from these two relations? Yes?
A is equal to C.
C. Yes, is that understandable? You are telling me that A is equal to B, and simultaneously you are telling me that B itself is equal to C. What is the conclusion out of it? Is that A is also equals to C. Yes, so you can immediately conclude that A is equal to C. This property is called symmetric. This property. Sorry, if I want to say it right, because this is true, we say that equality is symmetric. Because this is true that every number is equal to itself, we say equality is a reflexive relation. And because if A is equal to B and B is equal to C, I can safely conclude that A is equal to C. We say that the relation of equality relation is transitive. I don't need you to learn these words, but definitely I want you to understand what is going on here. Is that clear? Now let us switch to one of these properties. For example, let us consider this relation between numbers. So we learned that this relation is not symmetric because if A is less than B, I was not able to conclude that B is less than A. That was actually wrong. The other way around was true. Yes. So for this reason, this relation is not symmetric. I am not allowed to interchange these things without any changes in the sign. But now let me ask you, do you think this relation is reflexive? Why? Because if it is going to be reflexive, it means that any number with itself should satisfy the relation. It means that for any number, A should be less than A. But is it true or false? False. Yes. So it is not reflexive. But let me look at the last property. Do you think it is transitive or not? It is transitive, yes, because if A is less than B, and you tell me that B itself is less than a third number C, what can I conclude if I want to between A and C? Definitely A is also less than C, yes? So this I can conclude that A is less than C. So this means that this relation less than, yes, is not symmetric, is not reflexive, but it is transitive. And it is a very, very important property that I will use it over and over again. You need to understand. This is something that you really know it. I'm just drawing your attention to it, yes? If A is less than B, B itself is less than C, immediately clear that A is also less than C. But let me ask you about this. Let me ask you about this. Let us consider this relation and review it again. Do you think this relation is symmetric? Is it symmetric or not?
No.
No. Yes, because if A is less than or equal to B, there is no guarantee that B is also less than or equal to A. But is this reflexive?
Yes.
This is reflexive, yes? Because no matter which number A I choose, if I write A is less than or equal to A, is it a true statement or a false statement?
True.
True statement, because I just told you A is less than or equal to A is equivalent mathematically to write A is equal to A or A is less than A. Of course, this statement is true, this statement is false, and I just told you that if you have a true and a false statement, combining them with this or, the whole expression becomes true. So this statement is true, so this is also reflexive. Yeah, is that clear? Yes? Okay. What do you think about transitivity? Do you think this relation is also transitive?
Yes.
Yeah, it's clear, yes. When you say that A is less than or equal to B and B itself is less than or equal to C, am I allowed to conclude that A is less than or equal to C? The answer is yes. Is that clear? Okay, so the same thing you can discuss about greater than and greater than or equal to. Okay, forget about these things now. Let us go and discover other properties. So one famous property is this. If A is equal to B and C is any number that you like, yes, what can I do? I can add C to the left-hand side to generate A plus C. This is a new number. And I can add C to the right of this one and generate these two. If I tell you that I guarantee that these two numbers are equal, what can you conclude if you want to between these two? They are equal again. Yes? So it is very clear that I can add a number to both sides of an equality and keep the equality true again. If you start with a true equality, if you add the same amount to both sides, the new numbers are again equal. Yes, is that understandable? Yes. And of course, I can also subtract. A minus C is equal to B minus C. I can also multiply. Is that understandable? If two numbers are equal, I multiply this by another number, I multiply this by the same number, the results would be the same. Yes? And I can also divide. But provided that C is not 0, because I am not allowed to divide by 0. Yes? Is that clear? But now let us try to understand these things, for example, for less than relation. So I am telling you that A is less than B. And consider a fixed number C. Okay? If I calculate A plus C, and if I calculate B plus C, if I tell you that A is definitely less than B, what can you conclude about the size of this number and the size of this number? Yes?
A is again less than C. B.
No, A plus C is less than B plus C. Agree? That was it. Okay. Is that understandable? If I tell you that A is smaller than B, and I take a fixed number, c, add it to the left-hand side to generate a plus c, add it to the right-hand side to generate b plus c, how these numbers are these numbers comparable? Yes, again, but which one is smaller? The left-hand side remains smaller than the right-hand side. Is that clear? Okay, now if I do the same thing with subtraction, what do you think will happen with these numbers? I guarantee you that a is less than b. I choose any number that I like. I subtract it from a to generate a minus c. I subtract it from b to generate b minus c. Now I am asking you, do you think there is a relation between them, or it is not 100% clear? Yes?
It's not clear, because if a is a minus number, then the answer becomes positive. And if
I'm not multiplying.
No, if
I'm not multiplying. Be careful. So it might be you're confused a little bit. I want to make sure that everyone understands. Okay, so that's good that Ali actually mentioned this. So I hope that you see what is the point. I am not multiplying it. A is a so if you want, for example, do you agree that this is a true equality? Minus 3 is less than minus 1. This is true or false? It is true. Minus 3 is less than minus 1. Okay, let me choose a negative number. For example, minus 10. Okay? And then I would write minus 3 minus 10. I am subtracting my number from the left-hand side. Minus 3 is my number. I subtract this number from mine. It becomes positive 7. Yes? And then I do the same thing here. This becomes minus 1 plus 10, which is positive 9. So again, 7 is less than 9. Is it true or false? True. Of course, this is not a proof, but I just want you to understand that probably you were mistaken. Yes? So, this is also true, but probably what Ali is mentioning is this property that you have to be very careful, and that's a very, very important lesson for today. Okay? So, if I tell you that A and B are equal, if you multiply the left-hand side by a number and you multiply the right-hand side by that number, then the results are the same. But what happens here? If I tell you that A is less than B, and I give you a fixed number C, I multiply the left-hand side by that number, I multiply the right-hand side by that number, can I guarantee that the left-hand side is still smaller than the right-hand side? The answer to this is no, and that is the reason that you brought up. So the answer here is no, because if C is negative, this is not going to work. Yes? So let me give you an example. Let me make the example simple. I have 1 less than 3. I choose C to be 5, for example, a positive number. I multiply the left-hand side by 5, I get 5. I multiply the right-hand side by 5, I get 15. Still, 5 is less than 15 is a true statement. So I started with a true statement, and I took a positive number. I multiplied the left-hand side and the right-hand side by that positive number. But what I get is still true. But let me change C from 5 to minus 5. Okay? So this was true. This is still true. But now let me multiply this by minus 5. So it becomes minus 5. And multiply this by minus 5. If I insist to keep this one is false. Yes? Okay, can I make it right? Yes, I can make it right by doing what? Right minus 5, right minus 15, but I need to learn to swap the sign. Yes, so that is actually very, very important. So this is probably the only new lesson that you need to be careful about. If you have an inequality, and if you want to multiply both sides by a positive number, don't worry, just multiply. Whatever you get is again true if you start with a true statement. But if you want to multiply by a negative number, you can still multiply by that negative number, but there is a price that you have to pay, and is to change the direction of this sign. If you start with less than, it becomes greater than. If you start with greater than, it becomes less than. And the other ways. For example, if you start with greater than or equal to, it becomes less than or equal to. So is that understandable? So this is the only thing that I want you to be careful about. So let me write this for you somewhere. If A is less than or equal to B and C is positive, then you can conclude that A times C is still less than B times C. This is something that I want to write somewhere. This is the only new lesson. And if A is less than B and C is negative, then what happens? AC is greater than BC. So that is very, very important. So let me put this in a box. Okay? Yes?
If both A and B are negative in the first case, that's not true, right?
Yes, it is still right. The point is that if you start with a true statement, you don't need to be worried about the signs of A and B. What you need to be worried is to start with the true statement. And then, if this is true, what you care is the sign of the number that you are multiplying. Yes? You don't care about the signs of these two. Yes, it doesn't matter, but this matters. Yes? But of course, if you start with a false statement, this doesn't work. This means that if you start with a true statement and then follow this rule, it is always generating true statements for you. Yes, that's the point. Of course, about division, the idea is the same. So it means that if A is less than B and C is greater than 0, you can also divide A by C, you can divide B by C, and then still this is less than that one. But if A is less than B and C is negative, you can divide, but the price that you have to pay is to swap the sign, interchange the sign. So that's also true. I haven't seen this one that I'm just going to tell in the book, but there is also another operation that reverses the sign. Can you imagine that? For example, what I'm asking you, if A is less than B, except for multiplying by a negative number, which is an operation here, operation is multiplying by a negative number. Can you think of another operation that gives rise to swapping the sign? Yes?
Square root or root.
No, you are right. So this is not. So you are saying that square root of A is greater than square root of B. This one?
No, it's not. So. It's not.
No, it is somehow so.
Well, it's.
So that's good to you brought this up. Do you think? So let us consider that A and B are positive. By the way, when I write like this, another way of reading this is A is between 0 and B. Why is that? Because 0 is, by the way, let me don't write this because I want to talk about them systematically. Assume that A and B are both positive numbers, and I know that A is less than B. Do you think I can conclude that square root of A is greater than the square root of B? No. In general, no. Yes? For example, 25 is less than 36. The square root of 25 is 5. Square root of 36 is 6. Still, this one is smaller than that one. Yes? But what about the numbers between 0 and 1? In that case, you are right. If I have a number which is between 0 and 1, then what happens? For example, I have 1 over 25 and 1 over 36. By the way, which one is bigger?
1 over 25.
1 over 25 is bigger. So 1 over 36 is less than 1 over, this is not also working, you are right. So 25. Then can I conclude a square root of this is 1 over 6, square root of this is 1 over 5. Still that's correct. Yeah, so this is not working, that's all. Okay, so forget about that. So this operation is not working. Another operation. Yes?
Can we test exponents?
Yes. But in exponents, this doesn't work generally. But in the exponents, that was what I was telling is true. For example, if I tell you that 2 is less than 3, which is a true statement, if I square this one, it becomes 4. If I square this one, it becomes 9. Still, the left-hand side is smaller than the right-hand side. But 5, so let me see. 1 over 3 is smaller than 1 over 2, yes? Again, when I raise it, what happens? It becomes 1 over 9, 1 over 4. It's still true.
But
Yes?
if the power is, or the exponent is a negative number, does it
Yes.
change the
Yes, that's the correct thing. So, negative power is an operation which takes you to the denominator. Yes, that's correct. So I would say reciprocal. So if A is less than B, what is this? What is the relation between 1 over A and 1 over B? So if I can say that 1 over A is greater than 1 over B, but there are some conditions. Do you think that I can immediately conclude this if I want to?
No, A and B can't be 0.
Yes, except for that.
A can't be negative?
Yes, none of them can. So for example, if I say minus 2 is less than 3, you agree with that one. That is true. But let me write the reciprocal. It's minus 1 over 2. Let me write the reciprocal, 1 over 3. Which one is smaller than the other one? Still this one is smaller because that's negative. So be careful. So I would say that that's also something that I want you to know. If A and B are positive, so let me write this in words. If A and B are positive numbers, are both positive, let me write it in that way, so to emphasize. Then, what can I say? If A is less than B, I can conclude that 1 over A is greater than 1 over B. Okay? And that is clear, yes? If I have 2 smaller than 3, if I find the reciprocal, it is 1 over 2. If I find the reciprocal, it is 1 over 3. If you insist to keep the sign the same, this is wrong, because 1/2 is not smaller than 1/3. So you need to remember you have to interchange the sign. What about if both of them are negative? Do you think still it is true? Both of them are negative. If both of them are negative, this is still true. Yes? So let me write A and B are both positive or both negative. So let me emphasize on the word both here. Then this is also true. So this is good to know, even though they haven't mentioned it directly in the book, but it is very, very important to understand that there is another operation to change the sign. If you take the reciprocals, you have to learn to change the sign. Unless one of them is positive, the other one is negative. If one of them is positive, the other one is negative, the reciprocals also follow the same relation. Yes? So you don't need to interchange. Okay. Let me now discuss about two equalities to see what are those properties. Just draw your attention to them. Okay. So if I have two equalities, what can I do with equalities? For example, if I have A equals to B and I have C equals to D. So tell me, if I add A to C and if I add B to D, if I guarantee these equalities are true, what can you conclude if you want to about these two numbers?
They're equal, right?
They are also equal, yes? So the rule of thumb is that if I have two equalities, I can add them side by side. And still I have a true equality. Yes or no? What can I do with inequalities? Do you think this is very, very important? If I have this inequality and I have this inequality, I know that A is less than B, I know that C is less than D. And now I add A and C together, it becomes a new number. I add B and D together, it becomes a new number. How these two numbers are related, if there is any relation between them? Yes?
A plus C is less than
B plus D, yes? Is that understandable? I just want you to know, is that understandable for everyone? Because you say that A is less than B and C itself is less than D. So both A is less than B and C is less than D. The summands, both of them are smaller than the summands here. So it is clear this is smaller than that one. So that's also something that I want you to learn. If A is less than B and C is less than D, if you want to, you can conclude that A plus C is still less than B plus D. This is something that I want you to know. Okay, so now for equalities, do you think I can also multiply them? Of course, I can also subtract them, yes? Still they are true. Yes, so let me write this again. So I can write A minus C. That's also, I hope that you can convince yourself that's also the, okay. So, yeah. Do you think this is true?
Yes.
So you see, for equalities, both of them are true if I add or subtract. Now I am asking you, for addition it was true, but what about subtraction? Okay, if you say no, you need to bring me an example to motivate that this is not correct. Yes?
D can be so much larger than.
That's not an example. That's explanation, that's good, but can you cook up numbers that everyone can see them in front of your eyes? Yes. You turn your idea into a numerical example. I'm just cleaning, you can think. Yes?
A is 1, B is 2, C is 2,
So you just A is 1, B is 2, C is 2,
and D is 5.
D is 5. Okay, let us test. Simon is telling that A is less than B. Yes, A is less than B in this case is true. And then C is less than D if in this case is still true. Yes. But now, what is A minus C? A minus C is 1 minus 2, which is minus 1. What is B minus D in his example? B minus D is what? 2 minus 5, which is minus 3. Yes? But is it correct to say minus 1 is less than minus 3?
No.
A minus C is B minus D. No, this one is not less than that one. So that's very, very good. Thank you very much. So that was very good example. So you see that this is not true. So you have to be very careful. This is something that I want you to understand because most of the people don't value these things. So don't take things for granted from equalities to inequalities. Of course, most of them were correct, but you see that there are some exceptions, and that is one of those exceptions. So let me just write and cross it over. So you are not allowed to subtract inequalities if you want to keep the inequality true. Yes? But if I insist to subtract, can you cook up a method for me? I give you two inequalities and I insist you to somehow use subtraction operation. In this way it didn't work. The natural way failed to work. Yes? So can you find another way that I can see what happens here? So you know I can add inequalities side by side, even though it seems very natural that I can also subtract side by side, but it was not true. So don't rely on it at all. You have to be very careful. But now if I want to have the subtraction operation somehow involved, can you tell me what to do? Yes?
D has to be smaller than
No. We don't know. A and B are comparable. We know for sure that A is less than B. We also know that C is less than D. We don't know anything about the relation of these pairs of numbers with those pairs of numbers. Yes? Yes, Ali?
If A or C is negative.
No, we don't know if they are negative or not. But my point is to somehow use subtraction operation. So let me tell you what I mean by that. First of all, if C is less than D, can I conclude that minus C and minus D? By the way, can you tell me what sign should I put here? C, I guarantee, for example, assume that C is less than D. What can I conclude about the size of this number and that number? Yes?
C is bigger.
This one is bigger. Why? Because I just told you, if you multiply the sides of an inequality by a negative number, you have to flip the sign. I am multiplying both sides by minus 1. You see, C is less than D. I multiply this side by minus 1. I multiply this side by minus 1, but this is the only lesson that you learn today, which is very important. If you multiply both sides of an inequality by a negative number, you have to respect that you are changing the sign. Yes? But minus 1 times C has a better name. It's minus C. Minus 1D has a better name, and that's minus D. So hopefully this should be a matter of seconds for you to understand from now on that if C is less than D, minus C is greater than minus D. Understandable? But can I write this in the language of less than instead of greater than? Yes? If minus C is greater than minus D, I can conclude that minus D is less than minus C. Is that understandable? Yes? So you see, I multiplied by a minus sign. I have to change the sign. But I told you that I can interchange these things. Again, the price that I have to pay is to change it back. Now, what I am telling you, from this one, if you tell me this is true, based on this argument, I prove this is also true. Okay? And then let me write them side by side. A is less than B, minus D is less than minus C. I do not subtract, I add. So what I do, I add this one to that one, less than, I add this one to that one. Can I add? Yes, because we just told that we can add, but we are not allowed to subtract. Yes? So what I did, I multiplied this by a minus sign. I have to change the signs. I use this trick to interchange the numbers and put it back in the form of the original sign. And now I have one inequality here, another inequality here with the same sign. I can add them side by side. Yes? And then what is a better name for this? Is A minus D. What is a better name for that? Is B minus C. So this means that this is a little bit complicated story. So if A is less than B and C is less than D, even though that was wrong, but this is true. Yes, this is true. A minus D is less than B minus C. Yes, is that understandable? By the way, intuitively it is very clear, because you are telling me that A is less than B. For example, if this is the x-axis, here is A, here is B, because A is less than B, so A should be on the left side of B. But now you are telling me that from A, I am subtracting a bigger number, yes, and from B, I am subtracting a smaller number. B by itself is larger than A, yes. Now what I am doing, I am subtracting D from this, I am subtracting C from this, and I know that D is larger than C, yes. Even if I don't do this, this is always greater than that one, let alone that I subtract a bigger number from this one and a smaller number from that one. So this is clearly A minus D should be less than B minus C. So that is very, very important. You are allowed to add inequalities side by side, provided that they have the same signs. Yes? But you're not allowed to subtract. If you insist somehow to make the subtraction involved, you have to do it in this convoluted way a little bit. Is that understandable? Okay. Now, let me start now another topic. We want to solve inequalities. What do I mean by solving an inequality? So here, for example, I would write 2x plus 1 is less than 5. Okay? And I ask you to solve the following inequality. What does it mean? Can you say that this inequality is true or false? No. We don't know because we don't know x. How should I know that 2x plus 1 is indeed less than 5 or not? Because 2x plus 1 is not known to me yet. So solving inequality means, again, like solving equations. Yes? We don't say solve equalities. We say solve equations. But when it comes to inequalities, we say solve inequalities. Okay, so it means find all possible values for x so that when you replace x with those values, this statement becomes true. Yes? Is that clear? For example, let me make it a little bit simpler. So x plus 1 less than 3. For example, do you think x equals to 0 is one possible answer for this inequality?
Yes.
Yes. Why? Because if I replace x with 0, 0 plus 1 is 1, which is indeed less than 3. So this is one possible solution. What do you think about x equals to 1? That's also a possible solution. What about x equals to 2? This is not a solution. What about x equals to minus 10? It's also a solution. So you see, you have a lot of solutions. Well, how many solutions do you think there would be here? Infinitely many. Yes? Can you tell me what are those numbers if you want to write a statement for them? What are those numbers that satisfy here? Yes?
Any number below or equal to 1.
No.
What? Oh no, this one. The third.
Yes, so you said below or equal to 1, so you mean this. Yes, this is not correct. There are more than this.
Oh.
Yes? Yes, Rasmus?
Shouldn't be x is smaller than 2.
2. Yes? X less than 2, they are not the same thing because you are not considering 1.1, 1.2.
The first one.
This one?
Yeah.
This one, I'm talking about this
Yeah,
one.
confused.
Even in that case, the answer is still this.
No, what?
We will come back to it, but let us talk about this, don't get confused here. If you write this for that, that is not true. This is the correct answer. Yes, and don't think they are the same thing.
No.
Yes, if you are working in natural numbers, they are the same thing. Yes, because you are telling me that this is 1, this is 2. If I ignore these numbers, yes, you are right. Less than 2 automatically means less than or equal to 1 because you are not considering these numbers. Yes, so these are not equivalent, and the answer to this is actually this one. Okay, so how we solve the problem, the good news is that you really don't need to learn something new. Everything you have learned for equations will also work here, but I want you to understand why. If I have x plus 1 less than 3, I want to make x alone. Yes? So I need to get rid of this 1. So I have to add -1 to both sides. Am I allowed to do this? Yes, we discussed about that. If this is less than that one, I can add the same number to both sides. So I added -1 to both sides. And then what happened? I get rid of this one that I don't need it. And then 3 plus -1 becomes 2, and this inequality. And that is your solution. Yes? But again, I will not do this because there is a faster way to do it. Exactly like equalities. You just take this one from the left-hand side and move it to the right-hand side and change the sign. Again as before. So if I want to solve this, that is completely correct way of doing it. But x plus 1 less than 3, I move 1 to the other side. This becomes 3 minus 1. And then x less than 2. That would be the answer. Another thing that is you need to learn in this lesson is they ask you to draw a diagram for the solution. If you want to draw a diagram for the solution, what you're supposed to do, you take this x-axis, usually you put the origin and you put this number, 1 and 2, and then change your color, for example. It is less than 2, it is not including 2 itself. You have to show it by drawing a hollow circle here. It means that I am excluding that point, and then you can color this side. Okay, and then you put an arrow, it means that it continues forever. So this red line that you see here is a graphical representation of your solution. So this is something you need to know in the book. They ask you to solve an equation and represent the solution on an axis. So that is good actually to understand what is going on. Yes, is that clear? So let us go back, for example, and solve that inequality. If I want to solve that inequality, what I'm supposed to do? So what I'm supposed to do is this. I would say 2x plus 1 is less than 5. If I want to be very strict, I have to add -1 to both sides. Yes? And then this -1 and that -1 are cancelled. 5 and -1 becomes 4. I want to make x alone, so I have to multiply both sides by 2, 1 over 2. Or let me divide. We divide both sides by 2. Here you have to be very careful. Am I allowed to divide? Yes, but you need to be careful. If you are dividing by a positive number, you don't need to be worried. If you are dividing by a negative number, you have to remember to change the sign, otherwise it would be wrong. But here, because I am dividing by a positive number, I don't need to change the sign. I will keep the sign the same. And 2 and 2 are cancelled, so what is x? And 4 divided by 2 is 2. This is less than. So that is the solution for this. Okay, what is the meaning of this solution? This tells you that if you choose x, any number, even slightly smaller than 2, take that number and put it here, this becomes a true statement. Yes? And by the way, solving inequalities could be very, very hard, but still we are solving inequalities in one variable and of first degree. It means that the highest power of x that appears is 1. Yes? And we have only one variable, and for example, x. Is that clear? Okay, now, from now on, I will not solve it in this way. I want you to understand why this method works. But if you give me this inequality I want to solve, what I do, my goal is to make x alone, so I move 1 to the other side. It becomes 5 minus 1, so 2x less than 4, and then I divide by 2. Yes? So it is faster to do it in that way. But if someone asks you why this method is working, you should be able to explain to that person, because of the properties of inequalities, we are allowed to do these operations. Yes? Okay, let me now go to a diversity of problems here. We have to practice this. Solve the following inequalities. And represent the solution graphically. Okay, so number one, so minus 5x minus 2 is greater than or equal to minus 14. Okay, so let us solve this problem. Remember this word. Still, you see, I am using the word solve, and I am using inequalities. Okay, if I want to solve this, again, your goal is to make x alone, preferably on the left-hand side. Okay, so what I have to do, I have to get rid of this minus 2. I have to get rid of minus 5. So I move minus 2 to the other side. So I keep the sign the same, you see, because this operation is not one of those operations that will change the direction. I move minus, so minus 14 is already there. I add positive 2 to both sides. The net effect would be moving minus 2 to the other side. And then what you do, you simplify a little bit, it becomes minus 12. And now x is not alone. So what I am supposed to do to make x alone, I have to divide by minus 5. So just let us write this patiently. You see, I am dividing this side by minus 5. I'm also dividing this by minus 5. But what I have to be careful about, because I am dividing by a negative number, this is the only thing that you have to be very careful. You have to flip the sign. Yes? Is that understandable? And then simplify. Minus 5 and minus 5 are cancelled, so this is x. And then minus 12 minus, this is cancelled, so it is 12 over 5. And this is less than or equal to. Yes?
What would you do if you had to divide by a variable?
Oh, that's a very different problem, yes.
Okay.
So that's why I don't know why this is absent from Swedish curriculum, but we will study them in our studies. Yes, that is not possible. So you need to divide, you need to discuss about different scenarios of x, something like that. It's a completely different story. Okay, so if I want to represent that, you don't need to be very precise, by the way. You just take your pen, you just put O, the origin, and then you don't need to be precise at all. 12 over 5 is 2.4. So for example, I can say 1, I can say 2, I can say 3. So I would say that this is exactly probably this. You don't need to be very exact. So here, this is 12 over 5. But 12 over 5 should be included. This is a have to. You draw a small circle and you fill it up. This you have to show in the diagram. So it means that you are respecting the fact that 12 over 5 is indeed included. Yes? And then on the left hand side or on the right hand side, x should be less than or equal to this number. So you just draw it with a different color or whatever, and then you just put this one. So that is a graphical representation of the answer. Yes? Is that clear? Okay. So let me solve another problem. So number 2. And by the way, I think you can solve the problems yourself. Let me write some of them for you and then wait a little bit for you. Just only 2 of them. I think that is enough for today. So number 3, these 2 inequalities. So 5 times x minus 4 minus 6 times x plus 2 is less than 4. And then let us write this one as well. So 3 times x minus 2 minus 5 times 2x minus 1 greater than or equal to 0. Okay. So I will pause recording. I want to wait for you to see what you get. That's a very simple task to do. So if you want to solve the first inequality, what you are supposed to do, you have to simplify, exactly like equalities. So I multiply, it becomes 5x minus 20. I multiply minus 6 inside, so it becomes minus 6x minus 12 is less than 4. 5x minus 6x is minus x. Minus 20 minus 12 is minus 32 is less than 4. I move minus 32 to the other side, it becomes 4 plus 32. It becomes minus x is less than 36. But if you stop here, that is not complete because we have to make x alone, so we have to get rid of this negative sign. For example, I can divide by minus 1, or I can multiply by minus 1, it doesn't matter in this case. But when I do that, this, let me just write it, I divide by minus 1, I have to divide the right hand side by minus 1, but because this number is negative, I have to flip the sign. But then this becomes x, this becomes negative 36. This is the solution. Okay? So then you need to represent it. So just go here. I don't know. For example, you can put O minus 36 is a big number. You don't need to calibrate it actually. You just put minus 36 there. But minus 36 is not included. This is a have to. You draw a hollow circle here. It means that you are showing that you are excluding the point itself. To the right or to the left, x is supposed to be greater than minus 36. So you just color this part and then continue. So that is a graphical representation of the solution here. Okay. And then let us do the other one quickly. So, number 3, I multiply 3 inside, so it becomes 3x minus 6. I multiply minus 5 inside, it becomes minus 10x plus 5, and that's greater than or equal to 0. 3x minus 10x is minus 7x. Minus 6 plus 5 is minus 1, is greater than or equal to 0. Then I move minus 1 to the other side. It becomes 0 plus 1, which is 1. Then I have to divide by minus 7 to make x alone. But the price that I have to pay because of dividing by a negative number is flipping the sign. Yes? This becomes x less than or equal to, this becomes minus 1 over 7. And then if you want to represent it, you just show the origin here. Minus 1 over 7 is to the left of this one. I'm just making it big, it doesn't matter. But less than minus this one, this time you have to include this. So you have to draw a circle here, but you fill it up. And then to the left. And then you put an arrow here. So that is the solution representation. Yes?
But if you don't include it, it should also be correct, no?
It should be what?
Also true.
No, it is not true. Yes, it is true, but that is not the whole story. Solve means find all. Even if you are missing one point, that is not for solution, it is not correct. When I ask you to solve, it means that not only find some of them, but find all of them. So if you exclude this, of course those numbers are still true, but you are missing a solution which you have to include. Is that understandable? So if you draw a hollow circle here for the solution set of this equation, that is wrong.
But I'm thinking about, you know, the symbol is equal or.
Yes.
Yeah. So if you write less, then it should also be true because.
Yes, it is true because you see, no, what I'm saying, you are confusing two things. If x is less than or equal to minus 1 over 7, there is no, if x is less than minus 1 over 7, it is also guaranteed that definitely it is less than or equal to minus 1 over 7.
Yes.
This is true. But this is a different problem. Here I am asking you to solve. To solve means find all possible values. Yes? You are not allowed to exclude if something works.
I understand.
Yeah. Okay, let me also try to see how this works in GeoGebra. Okay, so one thing that I want you to know, let us see if GeoGebra is capable of solving inequalities as well, because I don't see any instruction for inequalities in GeoGebra. So let me go to cast view, and let me close the other one, so we don't need them. So I don't need graphics. Okay, so here, when I press solve, I don't see any inequalities in my list of options here. All of them are equations. But let me try to use our chance to see if it works for this one. Let me punch this one, regardless of the name of this one is not equation. The name of this is inequality. So I will go to solve again as before. But then let me punch that one, so I would say 5, x minus 4, yes, and then I go outside, minus 6 times x plus 2, yes, and then I put this equality less than, okay, you also have it on this keyboard. If you want to punch this, you can use this one. And then here I have less than 4, and let us see if GeoGebra solves this inequality. Yes, it solves. Yes, so actually I don't know, because that was misunderstanding from my side. I was thinking that we should have solved inequality, but the same solve command will also work for an inequality. Yes, so if you put that inequality, it will solve you. Is that my answer right? Yes, you see we got the same answer. X is greater than minus 6. Yes. Okay, so I think GeoGebra is also capable of solving that. And then let me also show you another one. So that is also very good to learn about. That is probably, it's very important to know. So let me, for example, go to guest mode. So we don't need to go to guest mode. So let me just go here. Okay, so we make it, this is Wolfram Alpha. I want you to know about this very brilliant website. So, and then this is very important. So you can just type whatever you want to. You really don't need to follow exact syntaxes or something. Yes? So for example, let me punch this one now. You want to solve, so it is actually using AI somehow. So I would say solve, just like that, because I want to solve something. I don't know, I open pair of brackets to put my inequality there. So it becomes 3, x minus 2, and then I have minus 5, 2x minus 1. Yes? I don't know, I just punch this because I don't know the syntax. Apparently, this will understand what you want to do that. Okay, no, it's greater than or equal to 0. So let me just greater than or equal to. I just randomly punch things and 0. Yes? And then I press enter to see what happens. Yes, so you see, it understood what I mean because it is writing it in the normal language. Do you really mean this when you type that? Yes. So I really mean this, you see. I'm not following any syntax. You see, in Geogebra, if you remember, I had to start with capital S, for example. Here I just punch it here. Instead of greater than or equal to 0, I invented this notation for myself. And then you see that this understands what you say. And then if you go down, hopefully it will solve you. Oh, okay. It also did graphical tool for you, you see. So the answer is x is less than or equal to -1/7, which was the correct answer. And then it also draws some graphics for you. Yes? And it also gives you a lot of information related to this because it doesn't know which one you are interested in. It gives you a lot of extra information that you need. So that is a very, very important website. There is also an application. You can download it on this website. Of course, I have this. This is the person who invented Mathematical, which is one of the greatest softwares probably ever for doing mathematical computation. Stefan Wolfram is a genius mathematician, actually. And then there is a very nice feature. It really works. It gives you the solutions as well. Unlock step-by-step solution. So I have the premium version at home. So if you solve an integral, it not only gives you, for example, the answer, it also tells you how to solve the problem, exactly like the solution map. So it generates the solution map. So I really want you to learn about this wolframalpha.com. So whenever you want to do some mathematical calculations, you think about a way to put it, to ask it from the computer, and the computer realizes probably what you're asking, and then gives you a lot of information around that problem. Okay, so I will stop here. Thank you very much.